Okay, so we'll go ahead and we'll go through the do now. As always, if for some reason, I know I have headphones in to try to, so you can't hear Wrigley barking or anything else. But if for some reason any of the sound stops working, if you send it in the chat in here, I'm gonna try to go back and forth. And if you notice that within a couple minutes I don't respond to the chat, just send a reminder. I have my phone sitting right here. And so I can kind of access that as well. So for the do now for today, so no matter whether we are at home or at school, we'll always have a do now, just a way to kind of get us started. Before we go through the do now, I do want to just point out, I did put the bell schedule up here for today and tomorrow, basically like what we normally see at school. The only difference is fifth period. So no matter what lunch you usually eat for fifth period is going to be 10:35 to 11:25, no matter what. And then you have like almost an hour for lunch, which is nice. And then sixth period starts back up at its usual time. So I did want to just share that with you. So that way, if you need that, if your fifth period teacher maybe didn't say anything about it, those are the times. So everything is the same except for fifth period and lunch. It's a little bit different. For your do now sheet from last week, you can write none for Wednesday, Thursday, and Friday. So Wednesday, Thursday were the test days. Friday, you guys weren't at school. So you can just write none for those 3 days. So now what we're going to do is we're going to look at the do now. So the do now today is going back over some of the material from video 1 and 2. We're going to talk more about 2.1 and 2.2 after the do now. But for these questions, it's looking at heat, work, and how those affect internal energy. So we're going to focus a lot on heat, but we do want to talk a little bit about work as well. If you are taking physics or you plan to take physics, you'll talk much more about work. We're just going to barely touch on it. So if a system absorbs heat, what is the sign for Q? So when it comes to heat, heat is Q. We always are focusing on the system. Is the system absorbing or losing heat? So you always want to make sure that you're referencing heat in terms of the system. And you can think about, is the heat going into the system or is it exiting the system? So if it goes into the system, that's endothermic, into endo, Q is positive. If heat exits the system, that would be exothermic. So those are just kind of the two ways to remember. So when you're thinking about the system as well, you want to think based on heat, is the system gaining or losing energy? So if heat is going into the system, it's gaining some energy, so Q would be positive. So for number 1, Q is positive, so we can just put plus. Work is where it gets a little bit tricky because you have to be really careful with the wording of work. And again, you're focusing on work based on the system. So in number 2, the system does work on the surroundings. So work is done by the system. So if you are the system and you are doing work on something, you're putting force on something over a distance, you are using energy. So you are using energy. So the system is losing some energy. And so the sign for work would be negative. So again, if the system does work on the surroundings, work is done by the system, it's losing some energy. So W would be negative. So we would just have a negative W. And then number 3 is kind of putting together what we looked at in 1 and 2. And we're actually calculating the change in internal energy. So change in internal energy is delta E. And to calculate delta E, it's just Q plus W. So for delta E, we're doing Q plus W. And so it says the system absorbs 140 joules of heat and does 85 joules of work on the surroundings. And so we have positive 140, negative 85. And we know those signs because we just looked at that in 1 and 2. So if we take a look at our answers here, for number 3, we have delta E equals Q plus W. We have 140 plus negative 85. So delta E for number 3 is 55 joules. So for number 1, Q is positive. For number 2, W is negative. And then for 3, it's 55 joules. And so we're going to look more at the sign for Q and for W on the next few slides. But that's just kind of something to get us starting to think about heat and work. And I know we're thinking about it at 7:30 a.m., but what else are we going to do? So for this week, just like always, I wanted to put up what it's going to look like. I did change these a little bit yesterday based on what today and tomorrow, with us being completely online. So we are going to work through Unit 2, which is Chapter 5 in the book. That's thermochem. So we're focusing on thermochemistry now, heat, calorimetry, which I think for some people, that was one of the first things we did last year in honors. And so it may have been a while since you've seen MC Delta T, but so we're going to go through a lot of practice with thermochem. Unit 2 will have mastering. That's already available and up. It's due Thursday, the 29th. But if you actually go into mastering, you'll see that it's broken up by video. So it's actually broken up based on the video. So it will say like video, it'll say video 2.1 and then have some questions, and 2.2 have some questions. I can't remember how many points it's worth, but I can tell you that there's a lot of extra credit built in. I know I put in some extra tutorials and things like that are extra credit. The specific heat of a metal lab. So based on us being home today and tomorrow, that lab is now virtual. So I will tell you, I had the entire thing set up on Thursday for us to come in and do the lab today and tomorrow in person. But now with us being home, I recorded that on Friday. So hopefully we do have another thermodynamics lab next week. Hopefully we can get to that one in person. But I'll tell you more about the specific heat of a metal lab on the next couple slides. If there are any changes, any updates, I will update these lesson plans. So this is a Google Doc, so this gets updated as I make changes. And so you'll notice if there's any updates, it will be there. Really, we're only going to be focusing on the first 4 videos today. So you've already watched the first 2, hopefully. The second 2 we'll focus on tomorrow. And then Wednesday, Thursday will be lots of practice and some time to work on mastering as well. And then the weekly review number 6, I will hopefully get that posted this afternoon. So that'll be in Google Classroom. But again, you want to wait until we do some more practice and things like that. So with everything being online, especially today and tomorrow, and I know it's just a couple days, but I just want to remind you that all of the Unit 2 materials, so the Do Now, the notes packet, any of the practice videos, so I'm recording today and tomorrow, even though it's just kind of going over general information, those will all be posted under the Unit 2 materials in the classwork tab of Google Classroom. So I just took a screenshot of your guys' class period, and you can see it's got the notes, the Do Nows, and I know that there are some people on the Do Nows already. I can, see the little icons, but everything is there for you. So if you're like, oh, I want to go back and look at the Do Now, or I have a question on the lab, if you go through, everything is there for you. So just keep that in mind. So now I want to get into some questions from video 2.1 and 2.2. So this was a lot of conceptual background information. There wasn't much math in the first 2 videos. So there were some questions on units, the difference between a food calorie and a calorie, force, distance, velocity. And so I just want to kind of go through the units for you guys. So a food calorie is a kilocalorie. So like kilometer, it's just a kilocalorie. So when you eat something that's 100 calories, that's a food calorie. That's actually 100 kilocalories. That is also represented by a capital C for calorie. So if you see something that says it is 5 calories, but the C is capitalized, that's actually a kilocalorie. That's 1,000 little calories. If it's just a lowercase c, that's we just call it small calorie, little calorie. So we're really focusing on a kilocalorie versus a calorie. There are just different wording based on like, because that's what we use in food, things like that. For force, we're not going to be doing a lot with units for force, distance, but just so that you know them. And again, if you're in physics, you recognize these. Force is measured in newtons. So a newton is actually a kilogram times meter per second squared. Okay. Right, kilogram times meter per second squared. That is force, and then distance is just in meters, so we always use the metric system. And then velocity is the same thing as speed. If you're in physics, please don't tell me the difference. I know there's a difference, but for us, it's okay. Velocity is meters per second, or the speed is meters per second. And then energy, so we focus a lot on energy because heat is a type of energy. That's just measured in joules. But the way that we get joules is it's mass times acceleration. So it's kilograms times meters squared per second squared. So then when we're looking at energy, there are a couple things. Kinetic energy you'll be calculating for mastering. Kinetic energy is on your equation sheet. Kinetic energy is 1/2 mv squared. So for kinetic energy, we have 1/2 times the mass times velocity squared. So we have 1/2 times the mass, but that mass needs to be in kilograms, velocity needs to be in meters per second, because then that gives us kilograms times meters squared per second squared, that gives us joules. So you don't need to know how all of these are derived. You need to know that we measure heat in joules, and that when you calculate kinetic energy, mass needs to be in kilograms, velocity should already be in meters per second. The big thing is converting mass. So then looking at heat versus work. We focus a lot in thermochem on heat, but there is another type of energy, and that's work. Work is when you apply a force on a system. So to calculate work, it's force times distance. So force times distance will give us work. Now you can choose the sign based on whether the work is done on the system or by the system. And the sign for work and for Q are on page 3 of your notes. There's the table that shows your signs for Q, W, and delta E. Just always remember that you're focusing on the system. So if work is done on the system, that means that energy is going into the system, because something is doing work on the system. It's applying energy to the system versus by the system. So by the system is what we looked at in the do now. So just think about what it means about energy based on the system, and that'll help you determine the sign. And then when we look at heat versus work, so heat is energy that's measured by temperature. That's why we look at thermochemistry. And then work is just the energy required to move an object against a force. Again, we don't do much with calculating work. It's good that you know that work is a type of energy, and that we have to use work for calculating internal energy, but all of our calculations really will be based on heat, so based on Q. There was a question on endergonic versus endothermic. So notice that the beginning of the word is the same, right? So we have end, so ender versus endo. Gonic is just based on work. Thermic is based on heat. So if it's endergonic, that means work is going into the system. So work is being done on the system. And then endothermic, heat is going into the system. So the ending there, they're essentially the same thing in terms of the concept, but you're just focusing on work or heat. So there were some other questions on state functions. So we don't have to do a lot with state functions anymore. It's good that you know what a state function is in terms of a variable, and I'll show you how we can tell that. But we're not going to do a lot with like the definition of state functions anymore. So state functions are always a capital letter. So when we look at state functions, it's always final minus initial. So this triangle is delta. It's a Greek symbol. Delta means final minus initial. It's change in. So if we have delta T, that is change in temperature, that's calculated by final minus initial. delta E is change in energy calculated by final minus initial. So a state function is always going to be designated by a capital letter. So internal energy, which is delta E, is a state function. We calculate internal energy experimentally, and to do that, we use heat and work. So delta E is Q plus W. This is really all we do with delta E and with W, is just we use this equation like we did in the do now. Now some more with state functions. With a state function only depends on the initial and the final. It doesn't depend on how we get from initial to final. It only matters what is the initial value, what is the final value, so that we can calculate the change in that variable. So we always find the change. So what that means is it doesn't matter if we start at the bottom of a mountain and we're climbing up to the top of a mountain. We're starting at the same beginning point and end point. That's all we're concerned about. The change in elevation, that would be a state function. Distance is not. Distance is represented by a lowercase d. And that's because distance, we could go from the bottom of the mountain straight up to the top. We could just rock climb the side. Or if you take a road that goes all the way around, all the way up, that's a different distance. So when you're calculating the change in something, that is typically a state function. So no matter the path we take, we only care about initial and final. Again, if you are trying to designate something that is a state function, look for a capital letter, delta E, delta T, delta H that we'll look at. But distance is a lowercase d, that's not a state function. Q is a lowercase, not a state function. Work, lowercase, not a state function. So that's an easy way, kind of a shortcut of determining what a state function is. And that's really all we're doing with state functions now, because AP took a lot of what we used to do with state functions out. All right, so now I'm going to get into the lab. So before I get into the lab, are there any other questions that I didn't, maybe you had another question and it didn't get answered? There isn't anything in the chat, but I just want to make sure that if you think of anything else and you want to put it in the chat, go for it. So now we're going to look at determining the specific heat of a metal. So this lab, like I said, was supposed to be in person. So let's see, the gold group was supposed to be there today doing the lab. Green group was going to do it tomorrow. But now that we're completely online, we had to kind of be flexible and shift a little bit. So now it's going to be virtual. And really, it was just heating some metal, putting it into water. So for determining the specific heat of a metal, hopefully you read the background information of the lab. So the background information was everything on the front because there was a lot of helpful information in there. It gave you the specific heat of water, gave you MC delta T, gave you some information about calorimeters. So hopefully you read that. If not, just take a little bit, read through that once I give you time. And then the procedure, hopefully, I was going to say you read through so you knew what to do in the lab, but I'm going to do the procedure for you. So like I said, it's going to be virtual. I will share the procedure video with you in the chat. It was also in Google Classroom, but I'll put it in the chat for you so that it's right here. I do want to make sure that when you're watching the procedure, make sure that you're drawing the data table in your lab notebook. So there's a data table on technically page 3 of the lab that has masses and temperatures. So draw that data table into your notebook. If you don't have a ruler or a straight edge, just try to make it as straight as possible. But remember to give it a number and a title. Every data table that you draw in your lab notebook needs a number and a title. So data table 1, specific heat data, or data table 1, mass and temperatures. Whatever title you want to give it is up to you, but make sure it says data table 1 and then has a title after. This lab is going to be a little bit different. Instead of turning in a lab, well, you'll still turn in a lab report because that is part of the grade. But we're also going to do a lab quiz. So imagine it's an open note quiz with your lab. It's just a quick way to get your lab graded and back to you. So just imagine your lab is going to be your notes for this OpenNote quiz. But to make sure you do well on the lab quiz, just make sure that you know how to do the calculations, you understand the post-lab questions. There is no longer a data analysis, so I'm going to remove that. And then your conclusion. Basically, if you want to know what the lab quiz will be like, instead of your data, I will replace numbers in that data table and then just ask you questions. So based on the data I give you, can you calculate delta T? Can you do the calculations for the lab? And I'll talk more about that as we work through the week. So for the rest of class, so it's what, 7:52, you will take some time. I said 15 minutes. The procedure itself is about 10. You'll watch the procedure video. So just watch it on your own, record all of your data and observations in that section of your lab notebook. So you guys are going to do sample 2. You'll see in the procedure video that I did sample 2 and sample 6. I'm gonna have you guys do sample 2. Please just make note on your lab handout somewhere that your sample is lead. That's gonna be useful for the calculations. So just make sure, and if you need to come back and look at this, you can, or pop in the chat and ask what it was again. So you guys will do lead. After you watch the procedure video, you can get with a partner. It doesn't have to be your virtual partner that I picked for you. You can pick anybody that's in your class, whether they're green, gold, doesn't matter. So you can get with them via FaceTime or Google Meet or Google Hangout and start working on the calculations. The calculations are very similar to the pre-lab questions. I do have a video that goes through the pre-lab questions as well. I'll put that in the chat. So I'll put all the links to help you out in the chat. And then you can also work on the post-lab questions and conclusion. So again, there's no data analysis. I know the rubric says data analysis, but I decided to just cut that out. So we will just have purpose, procedure, pre-lab questions, data and observations, calculations. Remember, on the calculations, you need to label your calculation and then show your work. Post-lab questions, conclusion. So those are your sections. I am going to stay on this Google Meet. So even when you guys go off, so just like in class, I'm going to keep the Google Meet open until the end of the second period of class to answer any questions. So once you watch the procedure, if you have questions on calculations, or you have questions on post-lab questions, I'll be on here to answer whatever questions you have. And hopefully you should be able to get the calculations done for sure. And then hopefully even the pre-lab or the post-lab questions. So you very well could potentially get this entire thing done right now. The lab is due next Monday, the day of the lab quiz, but the sooner it gets done, the better. So in the chat, I did just put, if you want to check your pre-lab questions, I had made a video for pre-lab questions. I put the procedure video in there as well. And then I put, if you want some guidance for the calculations, I don't check, like I don't work through the calculations completely, but I do set them up for you. So if you want to use that to help as well, you can. So I will leave this open. So that way, if you have questions, you can jump back on, you can type them in the chat, you can unmute, but today's just going to be a time for you to work on lab. Okay, so you don't have to leave this Google Meet open. If you want to leave the Google Meet and just come back if you have questions, that's fine. But I will stay on here until 9:05 just to be able to answer questions that you guys might have.